NASA's latest superstar, the James Webb Space Telescope, seems to be on a winning streak as it captures one out-of-the-world image after another. In this video, we take a look at one of the most recent photographs taken by the JWST. We're talking about the infamous Orion Nebula in its entirety. Stay tuned and watch. If you're even remotely interested in stargazing, you must have heard about this gaseous cloud situated in the Orion constellation. Only 1,350 light-years away from us, it remains the closest star-forming region to Earth and is thus a popular cosmic element to be observed with the naked eye. The Orion Nebula contains a very young open cluster, known as the trapezium cluster, due to the asterism of its primary four stars within a diameter of 1.5 light-years. Two of these can be resolved into their component binary systems on nights with good seeing, giving a total of 6 stars. The stars of the trapezium cluster, along with many other stars, are still in their early years. The trapezium cluster is a component of the much larger Orion Nebula, an association of about 2,800 stars within a diameter of 20 light-years. The Orion Nebula is in turn surrounded by the much larger Orion Molecular Cloud Complex, which is hundreds of light-years across, spanning the whole Orion constellation. 2 million years ago, the Orion Nebula cluster may have been the home of the runaway stars AE Aurigae, 53 Arietis, and Mu Columbae, which are currently moving away from the nebula at speeds greater than 100 kilometers per second. Observers have long noted a distinctive greenish tint to the nebula, in addition to regions of red and of blue-violet. The red hue is the result of the Ha recombination line radiation at a wavelength of 656.3 nanometers. The blue-violet coloration is the reflected radiation from the massive O-class stars at the core of the nebula. The green hue was a puzzle for astronomers in the early part of the 20th century because none of the known spectral lines at that time could explain it. There was some speculation that the lines were caused by a new element, and the name nebulium was coined for this mysterious material. With better understanding of atomic physics, however, it was later determined that the green spectrum was caused by a low-probability electron transition in doubly ionized oxygen, a so-called forbidden transition. This radiation was impossible to reproduce in the laboratory at the time because it depended on the quiescent and nearly collision-free environment found in the high vacuum of deep space. Interstellar clouds like the Orion Nebula are found throughout galaxies such as the Milky Way. They begin as gravitationally bound blobs of cold, neutral hydrogen intermixed with traces of other elements. The cloud can contain hundreds of thousands of solar masses and extend for hundreds of light-years. The tiny force of gravity that could compel the cloud to collapse is counterbalanced by the very faint pressure of the gas in the cloud. Whether due to collisions with the spiral arm or through the shock wave emitted from supernovae, the atoms are precipitated into heavier molecules and the result is a molecular cloud. This presages the formation of stars within the cloud, usually thought to be within a period of 10 to 30 million years. As regions pass, the gene's mass and the destabilized volumes collapse into disks. The disk concentrates at the core to form a star, which may be surrounded by a protoplanetary disk. This is the current stage of evolution of the nebula, with additional stars still forming from the collapsing molecular cloud. The youngest and brightest stars we now see in the Orion Nebula are thought to be less than 300,000 years old, and the brightest may be only 10,000 years in age. Some of these collapsing stars can be particularly massive and can emit large quantities of ionizing ultraviolet radiation. An example of this is seen with the trapezium cluster. Over time, the ultraviolet light from the massive stars at the center of the nebula will push away the surrounding gas and dust in a process called photoevaporation. This process is responsible for creating the interior cavity of the nebula, allowing the stars at the core to be viewed from Earth. The largest of these stars have short lifespans and will evolve to become supernovae. Recently, over 100 scientists from 18 countries corroborated on the early release science program and were able to process the Orion Nebula's image using data from the JWST. And the stellar picture could easily be misconstrued as a magical creature with spread-out wings made of pixie dust, but these are merely extensions of the Orion bar. In line with James Webb's primary objective of studying the cosmic genesis, the photo reveals complex details regarding the formation of stars and supernovas during the first million years of the Milky Way's evolution. Relying on the James Webb's ability to detect infrared light, scientists zoomed deep into the nebula's numerous spectacular structures, scaled to 40 astronomical units, or the size of our solar system. They identified Proplyds, an extremely illuminated central protostar surrounded by a disk of dust and gas in which planets form, and even the subsequent layers of dust within the Orion. Further, a prominent trapezoid cluster of newly forming stars has also been captured. In this image, we are looking at this cycle, where the first generation of stars is essentially irradiating the material for the next generation, explained Edwin Bergen, University of Michigan Chair of Astronomy and a member of the International Research Team. But the team doesn't intend to stop here. As Bergen added, "We hope to gain understanding about the entire cycle of star birth." Well, that's all for the video. Hope you enjoyed watching this one. Thanks for watching.